You are welcome to Trinity Mathematical Clinic. I am your host today and my name is Mega, and we shall together dive into integration further and some other techniques we can apply on integration. Now today we are going to be looking at the substitution method in integration, aka use substitution. And the question is, why is this actually necessary and why is this important? The reason for this particular technique is actually needed in order for us to convert or reduce any particular integral into a more simpler integral so that it will allow for easier integration. That is the essence of that. And how do we carry out the use substitution method? The use substitution method begins with you understanding what is any particular function in the given integral that looks a little bit somewhat complex or more than usual. You pick that out, and this is where, so what we are going to do right now is that we are going to pick a new variable for the function we want to reduce and also differentiate the function, carrying out appropriate substitution to integrate. So this is what we'll do now. So look at this example. In the first example, we have evaluate the integral of 3x raised to the power of 2, open bracket, x raised to the power of 3 plus 5 raised to the power of 7 dx. Now, when you look at this particular function now, this is 3x squared multiplying x raised to the power of 3 plus 5 all raised to the power of 7. This is a function, and this is also another function. So the question is, what is the complex function here? The complex function here is really not this guy, not 3x squared, because 3x squared is simple, but there is a guy in his bends, and that function in his bends is x raised to the power of 3 plus 5. So a policeman knows that this guy, there is something about this guy, so they have to ask for a paper. You come out of your bends, and the bends is actually the brackets raised to the power of 7. So this is the complex function in this case. So we can bring this out by saying, by use substitution method, by saying let u be equal to x raised to the power of 3 plus 5. So if this is what we have now, what becomes of this? We have that then we should have that this integral becomes 3x raised to the power of 2 times x raised to the power of 3 plus 5 as assumed a new variable, and that variable is u. When we replace that, we have that to be times u raised to the power of 7 dx. So is it not simple? Yes, this is actually simple, but the issue is that you cannot integrate a function with respect to another variable. You can see that there is x here, fine, there is u here, good, but you are integrating this with respect to another variable, so there is a conflict in the positions of the variable. So what do? We have to what? Find for the x. How do we find for the x? We have to go back to our assumed function where u is equal to x raised to the power of 3 plus 5. So from our assumed function in u, we are going to find for the x. So the next operation right now that we want to do is to know what the value of the x is by revisiting our Yahoo function. So in this case now we can go on to say differentiating u with respect to x. Our u is actually given by u is equal to x raised to the power of 3 plus 5. Now when we differentiate it with respect to x, we have this to be given by du over the x is equal to the derivative of x cubed is going to give us 3x raised to the power of 2 plus the derivative of the constant is already 0. But then the purpose of this is to find the x so that we can carry out appropriate substitution. So in this, when we cross multiply, we have that du is equal to 3x raised to the power of 2 dx. Therefore, since we are looking for the x, we have that the x is equal to du all over 3x raised to the power of 2. So this is where we are now. So we have known the value of the x. This allows us to now substitute. we have the u part and we have the substitution part. So we have done the u part and we have differentiated. Now comes the substitution part. So substituting, we have this to be given by the integral of 3x squared times u raised to the power of 7 dx. This is equal to, by substitution, the same thing as 3x raised to the power of 2 times u raised to the power of 7. The x is given by times du all over 3x squared. Easy. Now, this is a term, correct? U raised to the power of 7, another term. Du over 3x squared is another term. What are they doing? They are multiplying each other. So since they are multiplying each other, we can simply cancel out the common terms here. This is a numerator over a denominator, so 3x squared cancels out 3x squared. So that we have this to be equal to the integral of u raised to the power of 7 du. So in this now, it's simple now. You can see how we can actually reduce a complex function in this form into a very, very simple function in this, which anybody can integrate. Even a great grandma of probably 960 something years can actually do this now. So that is a joke, please. So we can actually integrate this now so that we have this to be given by u raised to the power of, increase this by 1, the power by 1, we have that to be 8, and divide by the new power, which is 8 all over 8. And what do we have to do? Mind, this is a constant. This is an indefinite integral, so we have to introduce a constant of integration plus c, so that we have that the value of the integral is equal to this. But since it is a function of x and not a function of u, we cannot leave our result as this. So we have to express this in terms of x, so that we have our final answer to be given by u is equal to x raised to the power of 3 plus 5. So substituting, we have open brackets x raised to the power of 3 plus 5 raised to the power of 8 all over 8 plus c. Very, very simple. So this is for this particular example. So we're going to work on this one so that we can stabilize our understanding on the concept of the use substitution method. Now, we have b is given by the integral of x raised to the power of 3 all over the square root of 1 minus x raised to the power of 4 dx. Now, once again, with the eyes of a policeman, look at this particular integrand that is to be integrated. Which one is really like living a, what word do we use? Is it an exotic life, or, look at this numerator here. The numerator here is given as x raised to the power of 3. This is a simple function. This is x raised to the power of 3 is a simple function, a simple guy just going to church, not minding anybody's problem. But there is another guy beneath doing underground work. And that guy beneath doing underground work is actually the one in his GLK. And this is actually 1 minus x raised to the power of 4. So this guy seems like the more complex function over the one at the numerator x raised to the power of 3. So what do? We bring this complex function out, 1 minus x raised to the power of 4 in the roots by saying, introducing the u term, we're saying that let u be equal to 1 minus x raised to the power of 4. So what do we do in this case now? It means that the original integral becomes the integral of x raised to the power of 3 all over the square root of 1 minus x raised to the power of 4, as assuming a new variable, and that is u. So u with respect to x. And this can be rewritten as from the laws of indices. We can actually rewrite this as the integral of x raised to the power of 3 all over u raised to the power of 1 all over 2, where the root becomes the fractional indices with respect to x. But mind you, as usual, always remember that we cannot integrate conflicting terms with respect to another respective variable. There is a u term here, and we want to integrate this particular term with respect to x. So what do? In order to bring about a uniformity in this given integral, we have to revisit our assumed variable in u by saying that since we have that our u, since our u is equal to 1 minus x raised to the power of 4, what do we do to get for the x? We differentiate. So we're going to be differentiating u with respect to x to find the value of the x. So differentiating this now, we have that the u differentiated with respect to x is equal to, differentiating a constant 1 is going to give us 0. Differentiating minus x raised to the power of 4 is going to give us minus 4x raised to the power of 3. That is the result of that now. So since we are looking for the x, we have to make the x the subject of the formula. When you run the subject of the formula for this, we should have that the x, therefore, the value of our dx is equal to minus du all over 4x raised to the power of 3. So this is it now. So now that we have gotten for u, we have differentiated. The next thing is to get for this substitution part, where we'll make appropriate substitution. So we say substituting we have from this integral, we have here to be given by the integral of x raised to the power of 3 all over u raised to the power of 1 all over 2 dx. Where the x has a value and it is given by this, so we have that to be equal to the integral of x raised to the power of 3 all over u raised to the power of 1 all over 2 times the x is given by this. So when we substitute, we have that to be times minus the u all over 4x raised to the power of 3. That is it now. So with this now, we can now simply cancel out common terms. We have x cubed here, we have s cubed here. So s cubed cancels out this s cubed, and we have our results to be given by. Take note that there is a negative term here. This negative term tells us that we're actually dealing with now a negative integral, which we can factor out of the integral. We have it to be minus the integral of what is left at the numerator. It is nothing other than 1 times the u, and that is going to just give us 1 all over what is left at the denominator. X cubed has been cancelled out, left with 4 and u raised to the power of half. So this time this is going to give us 4u raised to the power of 1 all over 2 du. We have that to be du. So what this simply means is that we have now achieved an integral that is conformal in every given way. So we are integrating the function in u with respect to u. So what do we do now? In this case, take note that this is a constant 4 attached to the variable. We can factor out this constant because it is simply multiplying it. So this is also the same thing as 1 all over 4 of the integral of 1 all over u raised to the power of 1 all over 2 du. And from the laws of indices, we can rewrite this as minus 1 all over 4 of the integral of u raised to the power of minus 1 all over 2 with respect to u. So in this now, we can simplify our work to be given by this. From this is equal to minus 1 all over 4. The integral of u with a power with respect to u is given by the process. This is given by u times u raised to the power of minus 1 all over 2. According to the rule, we add 1 to the power and divide by the new power. The new power is minus 1 all over 2 plus 1. Then with a constant of integration plus c. So that this is going to be given by minus 1 all over 4 times u raised to the power of minus half plus 1. That is going to give us 1 all over 2 all over 1 all over 2 plus c. So in this we have the results to be given by, this is going to be equal to this can multiply this. This is a numerator. Multiplying this numerator, that's going to give us minus u raised to the power of 1 all over 2 all over 4 times half. That is going to give us 4 times 1 all over 2 plus the constant of integration c. So that we have our result to be given by u raised to the power of 1 minus u raised to the power of 1 all over 2 all over this times this is going to give us 2. So we have here to be 2 plus the constant of integration. So therefore, we have our final result in terms of x to be given by minus open brackets u is actually 1. U is actually 1 minus x raised to the power of 4. So we have here to be 1 minus x raised to the power of 4 minus x raised to the power of 4 all raised to the power of 1 all over 2 plus the constant of integration. So this is just the whole idea on how we can apply the use substitution method. So the key thing you can actually take out of this is how do you know the complex function and the simple function? So isolate the complex function out of the given integral, give it a variable, differentiate it, substitute it back into the given integral. It reduces itself to a simple function when you carry out necessary cancellation and you are done. Integrate and you get a result. So thank you very much. You can try out these practice questions and try to do them, and also engage us with your answers in the comment section, and we are sure going to reply each and every one of you. Thank you very much and stay tuned. God bless you.